software called fSpy. So it's actually good because what I'm doing here is that you have free XYZ coordinates, directions here. You basically line up your XYZ in a particular place to find what we call vanishing points, meaning parallel lines that in reality these are parallel, but in our image, because it's a perspective image and a projective geometry, now these parallel lines are vanishing with respect to a particular point. So in this situation, for instance, you can utilize a software like this. The mathematics behind it is pretty simple, but I'm not going to go into too much detail about the mathematics of utilizing that. But there are good basically places that you can use that. So at this point, as soon as you see that, it is actually figured out what it is. And then you can say, okay, this was an iPhone 6S or whatever, and it changes that value based on how it is. And from this, you can basically say, okay, I want to use the third vanishing point here as well. You can now use the 3D. And from that, you can basically line these up. And this is very useful when you have regular rectangular buildings like the one that we have here, meaning that you're obviously knowing that these are hopefully all parallel and aligned. And through that hope that these are parallel and aligned, you can, in less than 3 minutes, let's say, you can see what the calibration parameters would be, because it figures out the vanishing points for you. And it's very interesting because now you can see the image, but you can also get, for instance, the plane that you have on the floor. So you can bring it down and it kind of looks like it's actually being placed exactly on the floor there that it's supposed to be at. So it's very cool, even though I didn't really spend that much time on this actually calibrating it, you can still get some information. Now, where this is important is not necessarily to perform, let's say, plumbness or dimensional compliance, but to actually utilize it for various different aspects. So you see, as soon as you change it, now everything is changed. And this was why I actually tried to do this, because then you can understand that it is so unstable that if you just move it slightly, then it goes from not having an answer to having an answer and to having a different answer. So it's not going to be accurate by no means whatsoever, but it would provide some indication in case you are interested in that, right? So now, where can we utilize this? We can utilize it, actually, there's a good other software as well that you can use that is called Blender. Now, you can use this in combination with Blender to be able to perform some sort of modeling. So, for instance, here, I've basically imported this in Blender. Now, I've actually modeled this column here by itself, and then I'm going to model this floor here as well. Basically, you put that there, you open up what type of mesh you're going to use, let's say plane. You can basically position it up or down. You can scale it however way you want. And then you can find out what it is exactly that you want to do. And then this way you can find, let's say, floor there. And then at the same time, I'm going to do a column on the side as well. So meaning with only one camera, as long as you can find those vanishing points with parallel lines that are hopefully a bit outside of the scope, but it's good parallel lines. And this is where you can go up and down. And this is where you have that column. Again, that column is not accurate, but it is good enough in terms of just visualization overall. You can get some visual there that this is the case, and you can get some idea of progress of how the construction is going forward. So here I've put it here just in back to kind of give you an indication of how different this is from the reality. But this is what you would get. Now, if you have multiple cameras, then you can utilize photogrammetry to really get it better. So this is for instance, this other column or this other wall there, that I wanted to put it there. You see, when you move it, it actually moves it as well. It tries to simulate how that vanishing point would look, which is quite impressive. But again, it's not sufficient. It's not enough for the accuracies that we might need. But it gives you an idea of how some existing software is available to perform and help you with the modeling of it, as well as just perform even the regular tasks that you have. Now, if you had calibrated this camera in the beginning and even in a better way, then you had even more opportunities to be able to play around with it, to be able to perform even more accurate. So this is, for instance, the floor slab on the top. You can basically play around, you can see where it has to be. And for the most part, it looks good, at least visually. So this is what I wanted to share with you today. I'm going to go a bit more into the other aspects of it, and then you can scale it in this side, or you can scale it in the other side as well, and you can play around with it. So I would recommend you to take a look at these softwares. Find, let's say, regular rectangular buildings, if it's a construction or something, and then just go and install these softwares and play around with it. You would be amazed what you can get, especially if you have like a large time-lapse image, how you would be able to get every frame available. You don't even need the BIM in this situation, but if you have the BIM, then you can superimpose that and perform the tasks that we just talked about as well, which I'm going to go through when we talk about the image processing section of our course.